Chapter 12, number 26. Find the orbital speed of a satellite in a geosynchronous circular orbit 3.58 times 10 to the 7 meters above the surface of the Earth. Okay, before we dive into anything, let's flag that they say above the surface of the Earth, not that distance from the center of the Earth. So we'll need to correct for that when we need to get the radius. We should, as always, draw our picture. So we have our satellite, a distance h above the Earth, and is going in a geosynchronous orbit. So it's tracking out a circle. And we know that for a thing tracking out a circle, the centripetal acceleration must be v squared over r. If we consider our satellite, it has only one force acting on it, of course, which is the force due to the Earth, gravitational force, and of course it's suffering an acceleration towards the center of the Earth, whose magnitude was just given. So we can say that the sum of the forces has to be m times a. So we have universal constant g times the mass of the Earth times the mass of the satellite over the distance squared is m times v squared over r. So now we just solve for v. V equals, we'll have v square say at first, v square, cancel out some m's, that one cancels with that, and then we're left with v squared equals g mass of the Earth over r. So v is the square root of g times the mass of the Earth over r. And then here's the thing that's sort of really important to remember. This thing now comes into place because our distance is not the surface of the Earth or the radius of the Earth, it's the combination of those, and so we really have square root of g mass of the Earth over r plus h. So I can throw in some numbers, and we get 3,072 meters per second, which, based on our fact that we have only 3 sig figs, is really 3,070 meters per second.